Hello viewers, welcome to my channel Science to Technology. In today's show, Rocket Monday, we're going to talk about Blue Origin's New Glenn. So let's dive deep into it. So this New Glenn, it's a heavy lift launch vehicle. What does that mean? That simply means it can put some serious tonnage in low Earth orbit. As in, like, there is only few countries that could even attempt that 30 ton to low Earth orbit kind of deal. So it's a big puppy, and it will be the first reusable orbital class rocket, like booster reusable from Blue Origin. Now it is tailor made for military contract. You have to understand this aspect. Whenever you are looking at a rocket, you may think of rocket equation. Oh, that's a good starting point, but that's not how rockets are built. Rockets are built by the constraints of finances. For example, Elon Musk was poor when he was designing the Falcon 9. What does that mean? That simply means the diameter is very thin. Why? Diameter is so small. So it can fit through underpasses. It does not need to travel all through the open roads and have overload pass and all that, which is very expensive. So he designed the thing to fit inside that financial constraint. He did not have the luxury of Boca Chica, where it's like, I can now afford the whole damn space, build the rocket, launch it just next to it. So you can see the design is affected by the financial constraint. And same goes with Electron, same goes with Astra. All rocket companies have a financial constraint. Now when this puppy was built, which is long ago, you have to understand, Jeff Bezos is a guy who has deep pockets, so there was no constraint on this. So at that time when it was designed, it was like, damn. So it was a big thing. And what did military ask? Military asked them very clearly, I want something very large, not heavy. Let that be very clear. They do not need very heavy things, but they do need large things, because again, optics are mostly empty space, but they do need enough space to fold the light back and forth. So large and high velocity. What does that mean? That simply means they are not targeting low Earth orbit, they are targeting geostationary. So that gave them the constraint. It's like, what do you are designing for? Give me something that has a huge fairing, and give me something that has high velocity, aka high delta V. So that is the target design element of it, meaning what was they were working towards, that's what they were working. A heavy lift vehicle for geostationary. And while other things can send technically same tonnage, they can't give you room. The room inside would not be that much. So that's what they're. And this is their second rocket. They did build New Glenn, New Shepard. It is a human-rated reusable rocket, which is, again, is a significant thing. And given the fact that he himself flew on it, that's a big flex. And be mindful, he, in terms of like Elon Musk and Jeff Bezos, he's the only one who has crossed Kármán line. Elon Musk has not done it yet. Now, like not orbit and all that does not matter. He did cross it. He crossed the Kármán line. So bro got it. Bro got his rocket. Bro good. So that's it. And this will be the first orbital class rocket. So this is New Glenn that we are talking about. So let's understand some design elements of it. Now this is a big rocket, and let that be very clear. This puppy was designed before Falcon Heavy, as in like the paper design and all that. So that's why I said, like, the money was not an issue for Jeff Bezos back then. So it's huge. And again, even against a Starship, it's not that tiny. It's not that tiny. It's damn good how, in terms of size, they, reached, basically, so to say. Height is 98 meters. That's like damn tall. And the diameter is 7 meters. More than enough space. Like, it's like, relax, brother. It's like, relax. So that's why the orbital reef that they are designing has such spacious quarter. It will be launching on these. So that's the point. And booster has 7 of these puppies, BE4 engines, Methalox engines. Now the design philosophy is very different. They are designing very high power engines, but fewer engines, and each engine is not going all out. Their design philosophy is completely different than Starship. Starship philosophy is go all out, as hard as you can, better metallurgy, better this, better that, better flow characteristics, going all out, all as hard as you can. While again, that's their philosophy. Their philosophy is completely different. Like, design it so it can handle that, but never push it to that much. Like, again, if one engine fails, again, in those scenarios, other 6 engine will fire up to that max level, but you should never require it to go that hard. Like it's a bit more conservative approach rather than this more maximalist approach, where they're maximizing what each engine can do. They're like, let's chill a bit. So that's the approach. And second stage has two BE3U engine, almost similar modified variants of what they have already human rated and certified. And why they are using that? Because that puppy runs on hydrogen and liquid oxygen. So bottom puppy is liquid methane and oxygen, liquid oxygen. Upper puppy is liquid oxygen and hydrogen. Now liquid oxygen and hydrogen does not give you thrust, but it does give you delta V, meaning once you are above the atmosphere, once you can truly expand the gases, like you have giant nozzle rather than tiny nozzles. If you have liquid hydrogen at that point in time, you're going to go fast and you're going to go far, meaning this puppy can throw small tonnage much further than this puppy can throw. Like if you are not going to low Earth orbit, if you are throwing things, like throw it as far as you can, like throw it to the moon or Mars, this puppy will win. Because again, now can this win? Yes, technically, because again, if they are smart, they will design a good payload fairing, and then that payload will have third stage. That will solve the problem. Again, that was done with space shuttle. They had some satellites that required more oomph than space shuttle had, so the space shuttle was low Earth orbit. So there and the kick stage did the low Earth orbit to upper stage. That can be done, but it has to do that, which again, a lot of development time. This is ready to go. So right now, as of now, it has like some serious room, and the fairings, 7-meter fairings, they learned from SpaceX. They are not even wasting money on building that boat to capture it. They're like, to just let it splash down, we'll capture it. This is one thing of engineering. You build it first, you build it better. SpaceX built it first. They learned through all the mistakes, and Blue Origin is like, I'll take that. Now, again, that's the small modification they did that because again, if any new company is doing that, because again, the design is old. If any new company is there, like, okay, build a catch hardware. Don't waste energy on basically landing legs and all that. Because again, money does not buy speed. It only buys time. Sorry, money only buys speed, not time. So ability to capture rocket directly where you gonna use it again saves exponential amount of time. Launching it downstream, then having paying for a boat, which is super expensive, B, then worrying about the environment, again super expensive. Their launch was delayed because of that. All of that issue goes away when you directly catch it back. So physics says don't do this, because rocket equation is like, no, you have to save too much fuel for that, and the only way to compensate is have bigger booster. Economics says build a bigger booster is cheaper, because again, you can launch frequently. You do not have to pay the sea asset. You do not have to worry about whether environment envelope there also. So that is far quicker, far more flexible. So 7-meter fairing, splashdown recovery. Let's see. So this is the design element of it. Now their first launch, this puppy happened on 7:03 UTC time, Universal Time Coordinate, and 16 January 2025. Unfortunately, I was in Delhi at that time. That's why there has not been much videos. I do apologize for that. That expo was kind of fun, heavy, and its booster failed to land safely. So booster did its job perfectly, then it came back, then it tried to reignite the engine, it did not ignite. Why did that happen? We do not know. Likelihood of us finding out is very low. Only chances that FAA will publish the report, hopefully, then we can know it. But I will not hold my breath for that. Blue Origin is not known for sharing all the information, so it did not work. However, that being said, they did deploy the payload to orbit directly in first try. That is shut up take money territory. Because again, you do not get paid for recovering your booster, you get paid for putting your payload into orbit. So that is a big thing. How big thing? That as of now, worldwide, I just wrote for safety reasons, because sometime in future it will change. First ever private space, in terms of USA, somebody has done that. To give you a context, SpaceX, when they built their Falcon 1, which was orbital rocket, it went boom, 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 three times. And then you had Rocket Lab, boom. And then you have Astra, it went boom 4 times. Then you have Firefly, again, boom. Relatory Space, boom. Virgin Orbit, boom. So fundamentally, it's a big thing to say and big thing to do, where it's like, no, this is my first launch and I'm going to launch it and it's going to go to orbit. And it's not going to be government or government-public partnership. No. One launch, go. It did that. So that is significant. At this point in time, if you have any doubt about Jeff Bezos' pocket, that should have been thoroughly eliminated. Bro knows his stuff. Bro has a good company. Bro is slow, but bro knows what he's doing. So that is done. Now, what about Starship? Well, here's the Starship is Mark II. You have to understand a lot of benefit of this design, because it's made after all the learnings of Falcon 9. And there's a lot of external learning that you can just look and learn. And there are certain internal learnings that they are like, only we know that. So Mark II does have that benefit. That's the core reason why this puppy is fully 100% reusable. And tower catch, again, Physics says don't do this. Economics says do this. Why? Physics is like, okay, rocket equation, do not save that much fuel. Again, even if you are saving 20% of the fuel, that 20% will give you the majority of delta V. Because again, rocket would be spent 80% of your fuel, the 80% lighter. So don't do that. Rocket equation is clear, don't do that. But economics is like, bro, it will save you so much time, so much cash flow to just launch it, commit back, directly catch it where exactly you have launched it. Penalty, your second stage would have to do a lot more heavy lifting, and your booster also requires a bit too many engines. But they do that. That's their approach that they are taking right now. And the benefit of doing all that hassle, their turnaround time would be super duper hyper quick. I can easily expect them to do almost 50 launches or 52 launches per year of Starship. It's doable for them. And even the Starship itself will come back on the next orbit and get the catching hardware done. And again, removing landing legs has significant advantage in terms of weight. So that's what's the benefit of learning from Falcon 9 and Falcon Heavy. And again, this is not fully reusable. However, let that be very clear. When they were designing this, they did had some concept and some design with certain complex flow geometry, where they can have a second stage that can enter as a heat shield also. Again, designs are there, patents are there, but they are not building it as of now, or they may be building it in secret, but they're like, okay, let's test this, let's refine this, and then we're gonna take all the learnings from this and put that into reusable second stage. But it can be done. The design has some leg room for that, so to say. So that's it. Now, another aspect is Starship is not ready yet, because again, if you want to send heavy stuff to low Earth orbit, basically space station, shut up, take money. But there is another problem, that they have not designed it for that. Starship is not built for Mars. I have no idea how the heck people got that. It's like, it's the same thing who people did not know about rockets or space, or they're like, oh no, the Dragon is made for Mars. And again, in 2020, he was claiming he's going to land on Mars, and there were like so lot of animation. That's what they're seeing. Oh, he's going to land on Mars. This is not for Mars. This is not even for Moon. This is only for low Earth orbit. Everything you see in this, in terms of design sketch, is designed specifically for Starlink satellite deployment. That's why the payload door is not designed to actually deploy anything other than that. That's why they're going to get the money. And after that, they're going to improve the payload fairing, then figure out whether how to have kick stage, or go with this idea of refueling this. Again, refueling is a second add-on. That's why design is not final on that. But again, that simply means if you have to compare for geostationary launch, design the goddamn door, design a refueling mission, all of that will add cost and time as of now. Again, they will complete it. Let that be very clear. They will complete it, but it will take time. And given the fact that the last launch blew up, the Starship blew up, it's gonna take a long time. So you have this going boom on a almost orbital debris, causing a lot of flights to go waiting pattern, versus this puppy, one shot orbit, done. Now again, if they had landed successfully, I'm pretty sure at that point in time, people are like, bro, what are you on? Like, what are you smoking, man? Pass the joint, man. It's like, it's something different. So New Glenn has a lot of room right now, because again, they have the fairings where it's like, ta-da, and they have speed for liquid hydrogen. It's like, ta-da. They have those things, meaning they have launch window where they are like good supplier from 2025 to 2028. Now again, that timeline could shrink if they turbocharge their delivery, or it could stretch out even more if another Starship blows up and becomes a debris field. So it's not out of the race. Let that be very clear. Way too many people are like, way too many, flavor with SpaceX. SpaceX is good. Blue Origin is not dead. Okay, it's like SpaceX good, Blue Origin slow, not dead. So what can we expect in the future? Well, this is the true power of USA. This is the golden age USA, basically just after World War II. So USA's true power was always in its capitalism, always in its private players. Now, to give you a context how big deal it is, Saturn V was built by multiple private players helping government to do this. NASA was the final say on the things, but Boeing made this, Rocketdyne made this, Lockheed Martin built this, Northrop Grumman built something else. So a lot of company came together to build that. Now, basically from that last 50 years, they have reached a point where big companies now, they have their own rocket system, which is almost at the same scale as Saturn V. That is significant. That's the true maturity. It's like, you may think, oh, they went backwards from Saturn V in terms of finances. And that's why I keep clarifying this. Physics, engineering, economics. Economics is always the base layer. They have progressed immensely in economics, and it shows. So basically, the space shuttle tragedy that did happen did give basically clipped off the wings of USA, but it did give them basically kick in the ass they needed in order to do commercial resupply missions, and now we are reaping the rewards of that. And competition is the best way from NASA's point of view to limit prices, meaning now they have a second heavy lift launch vehicle. Again, they can be like, hey, we can launch it in Falcon Heavy, or we can launch in New Glenn, meaning both price would be locked. Neither party can charge whatever they want to charge. So they're like, that's good. That's a good ethical way of keeping the price reasonable. That's good. Blue Origin is slow. Let that be very clear. This puppy should have been launched in 2020. This puppy was long, slow. So it's slow. Let that be very clear. But they are not stuck. Do not, under any circumstances, assume this company is stuck. Not only they have a human-rated engines, and not only their engines reached orbit in the first trial of ULA rocket, they're good. They know what they're doing, and things are working as expected. So they're gonna have a very big impact on upcoming race. And given the fact that their lunar lander concept is much simpler, the likelihood from now to landing on the moon can be done with this far more quickly. Rather than building a starship that you have to refuel God knows how many times, 15 times or 20 times, and then launching it on, and then landing, and then it's like, again, that's why Starship is built for one thing, Starlink deployment. It's not even for a lunar vehicle, and I have no idea how the heck people keep falling for, oh, it's built for Mars. No. Again, if SpaceX actually forces that, yeah, it will be like the same thing as Saturn V, where it's like, you could do it, it's just you can't afford to do it. You will do it one or twice, and then it's like, come back, we can't burn this much money. So again, you can light a cigarette with a lighter, or you can light it with a goddamn flamethrower. You can't afford the flamethrower. That's why I keep saying they have to have a third stage. They can deploy third stage from second rocket, dock it with the payload from another launch, done. 2 launches done, go home, everything you want to do. But if they're like, what if you have this, and what if you keep refueling this goddamn second stage? It's like, what if you don't do that? Again, that's why this is a good thing. Having multiple redundant paths to orbit, to moon, it's a good thing from a nation's point of view. Very good. Again, if you want space to thrive, this is a good news. If you want SpaceX to thrive, this is not a very good news, because that simply means now SpaceX actually have to be reasonable with their price. They cannot just like, hey, we are the only one who can do this, so we can charge whatever the hell we want. How Ariane 6 is doing to EU. So this was my presentation on basically what the heck is going on with New Glenn. Hopefully you have liked it, learned from it. In that case, please click the like button, share it amongst your friends. That will help me out. If you didn't like it, didn't enjoy it, I urge you to press dislike, press it twice to show me extra disappointment. Please leave a comment. I do try to reply to all of them. And please subscribe, press the bell icon if you're free. And as always, thanks for watching.